Good morning, good afternoon, good evening, wherever you are in the world. A warm welcome to our webinar today goes out to our customers, students, interested engineers, and last but not least, to our competition. With hundreds of thousands of wind turbines operating around the world, operations and maintenance is a key factor in maintaining low costs. SEMIKRON, with the help of utilities and owners we've worked with over the years, has helped develop IGBT-based products specifically for operations and maintenance. Our goal is not only to replace existing IGBT solutions, but to update them with the latest technology in order to increase reliability. My name is Emilio Meza, and I'm your moderator for today's webinar, Operation and Maintenance, a Stack Success Story. Before we get started with the presentation, some words about our webinar platform. In case of connection issues to the presentation stream or the sound, please try to reconnect using the button on the very top of your web browser window. In your browser, on the top right-hand side, you see the chat window, which you can actually hide to increase the presentation size. In case you have any comments or difficulties, please let us know via the chat. All messages are private. If you have any questions about the content, please mark your comment as a question with the Q&A mode button. We will try to answer your questions at the end of the presentation. The questions we do not manage to answer today will be answered later by email during the coming days. Also, during or even after the webinar, you can send us an email at webinar@semikron.com. Finally, we will also share the slides as a PDF file at the very end of the presentation. You will see the download button just below the chat window. Your presenter today is Timo Gassauer. Timo graduated in 2004 from the University of Applied Science in Stuttgart with a diploma degree in electrical engineering. He then worked as a development engineer before joining SEMIKRON here in Nuremberg. From 2012 to 2016, he worked for SEMIKRON Asia as a product manager in China and South Korea. Today, he is working in Germany for the product line Stacks, advancing global growth opportunities of SEMIKRON's stack business. Enjoy the webinar. Timo, the floor is yours.
Thank you, Emilio, for the really nice introduction. It's my pleasure to be here and talk about the stack success story and introducing the world of the power electronic stacks to you. So today I will talk a little bit an introduction about the power electronic stacks and what are the advantages and the benefits we provide to our customers here, and then also translating this into a real success story for specifically the operation and maintenance market before coming up with a quick summary conclusion for this webinar. So power electronic stacks. We are, as SEMIKRON, we are dedicated for power electronics. So that means we not only do direct thyristor chips and power, IGBT modules, but also power electronic assemblies. And here we have a really long experience of more than 40 years and already worked with more than 1,500 different designs for the different applications. And by today, more than 200,000 stacks are already running in the field. And we are serving all kind of leading electrical industries in the market. So what is a stack? When we define a stack, we talk about an assembly including the IGBT module and gate driver, capacitors, protection functions, sensors for the protection, DC link capacitors, and of course, cooling. We have off-the-shelf platform available, which you can buy as existing from the datasheet. For example, our SEMICUBE platform, but we also provide customized specific products based on existing designs or platforms, just really adapted to the specific needs of our customers. And of course, we are using the latest technology available on the market. It's from multi-level topologies, for example, up to silicon carbide, whatever is the best performance for your specific needs and application. We serve different markets. We work in mature markets like motor drives, solar, wind power, OEM business, as well as in the new emerging markets, energy storage, EV charging, everywhere where power electronics is required. And we can, with our optimized designs, bring in the right value for you. So based on the customer's on your demands, we provide products which enables you to participate in these markets worldwide, right in time, with reduced risk, technical risk. And we provide solutions for all kinds of requirements for a different level of integration, starting from module and heatsink, for example, but for example, automotive grade, up to our most common product, the standard power electronic stacks, including the semiconductor, cooling, and gate driver, which are pre-qualified and tested, up to customer-specific designs, and up to cabinet level integration. So in collaboration with our customers, we work and define the complete cabinet. We stop usually there where the controlling and software comes in. But we help our customers to provide the best optimal design for their needs, different kind of integration level. And of course, this all brings certain benefits. So in different markets, there are different needs. For example, if in emerging markets, you need a certain product innovations. And with this product innovation, fast time to market is super important to be right in time at the right, with the right product to meet the right demand. So here for the product lifecycle, we are supporting our customers to just have in-time deployment of the products. And also our global production network, 4 stack centers in France, Brazil, USA, and India, we are close at our customer site, so giving direct support close to your time zone wherever you are. With our manufacturing processes and also qualification processes, we provide the best cost control to you, and you just outsource all these, and we have a validated processes defined and procurement processes which supports you getting really the best out of your demand for your product. And last but not least, engineering experience. Our engineers with very long experience for the different applications dedicated to power electronics are here to help you to define an optimal design based on what is the requirement. Now, with these topics and these benefits we provide with the power electronic stacks, how does that translate to the operation and maintenance market? So we have one specific success story, which I would like to show you, really to introduce these benefits in these specific markets. So what are the challenges in this operation and maintenance markets? So by today, you have a high already wind capacity installed in the market worldwide, more than 650 gigawatt of capacity, which translates in more than 350,000 wind turbines in the field. And in the next years, the average age probably is going to up to 14 years of an average turbine. In the solar, it's similar, very high amount of gigawatt installed for the solar in the worldwide. More than 2,500 utility scale solar plants in US alone, for example. But also here we see an aging population of the inverters. So after installation of a solar plant or a wind turbine, the major concern of an operator, of course, is, or the requirement is cost of energy keeping low. But one of the biggest issue for cost of energy is the O&M costs. So the target of each operator is to reduce the wind turbine downtime, as well as reducing the operation and maintenance expenses. Of course, at the same time, increasing the lifetime of the turbine, increasing the reliability of the turbine. Each exchange of material and product costs increases the costs. One of the concerns is also that the turbines are not, especially in the aging turbines, are not performing as expected. And often spare parts are not available anymore. So these concerns need to be addressed. So we have one example. One customer came to us with a challenge of reducing the cost of maintenance for out of warranty system and also addressing a significant failure rate. So we were asked, based on the requirements of the customer, to develop a drop-in replacement for an IGBT stack for a specific wind turbine, with a goal to maintain competitive cost, not be more expensive than the existing version, but also reducing the reliability significantly up to 0.5% annual failure rate maximum. So looking at this system requirement we got from the customer and what the product specification, we were also looking at, okay, what in the end, what is the project sign off, what is need to be done. And here we have the product must run 6 months continuously in the turbine without failure. And the performance-wise, it must have a 9 degrees lower temperature given to the based on the temperature sensor given compared to the existing version. So there was quite some challenges here, which we addressed looking at our following our SEMIKRON stack development process. So the first part is really to understand the situation and analyze where we are. So we were looking at the original architecture of this turbine, and we analyzed the components within the converter and realized also it's not a really state-of-the-art design. So here we have some points where we can start to work on. Looking at the architecture on the right side, you see there are 3 parts. One is the low voltage part, the controller, the power supply connected to the bridge interface, where it's also an isolation between the high voltage and the low voltage side. And then you have the connection to the bridge module via a very long cable, and then addressing driving the IGBTs. And also then, of course, a cooling plate with a certain water flow to a liquid-cooled system. So these 3 parts we addressed to improve the system overall. IGBT module, the driver, and the heatsink. And the goal was also to improve the system, not only on the performance-wise, but also to reduce the failure rate and also reduce the catastrophic failures. So if there's a trip, if something happens, an external factor comes in, that you don't destroy the components, that just you can by controlled shut down the system and not replace the damaged components, which add to your costs. So how did we do that? Looking at the IGBT module, we were looking at the product which is installed, and we saw that it's a standard industrial system, or a standard industrial IGBT module has been used. So in order to improve the lifetime here, we were looking at the details. How to improve the lifetime or the reliability of a module. There are 3 factors. One is solder connection. So the chips are soldered to the DBC, and the DBC is soldered to the copper base plate. Over power cycles and then temperature cycles, we have a certain solder degradation over the time. And in order to avoid that, we could use sintered. So sintering the chips to the DBC, which will then increase the reliability. A second part is the connections, which are also soldered. So the connections, one is we can reduce or we can change to a pressure plate, for example, and have an even pressure on the DBC to have a low inductivity inside the system, but also have an evenly distributed pressure and decrease the thermal resistance here. And the third part is then remove the base plate, because the base plate with the thermal cycling will also add mechanical stress to the component. So if we remove these 3 parts, we could improve the reliability of the product. And if we use the product we used was a SCIM93, and here we already see a 3 to 5 times higher power cycling capability over the standard industrial module. So the SCIM93 automotive grade module, it has auxiliary contacts by springs. So it's not only easy to mount with a driver, because just you don't need to have soldered holes. You just connect it on the springs. but also you don't have the solder degradation on the contact points. Pressure contactor terminals for an even distribution and a low thermal resistance, no base plate, and the chip sintered to zip DBC. So we could reach a 5 times higher power cycling capability with this product. In the next step, we looked at the driver side. What can we do on the driver side? And the task of the driver is to have a galvanic isolation between the low voltage side and the high voltage side, protecting the controller and from the high voltage side in case of certain failures or short circuit, but also to pull power to the IGBT module to drive it with the right amount of power. Now, what we did is we added the isolation on the driver side, getting away from the bridge interface to the SEMIKRON driver, and avoiding and having on the bridge interface only the low voltage side. So that caused us that helped us to protect the controller especially in terms of circuit protection. Sorry, in terms of short circuit protection. So we added also an additional power supply on the driver side, which is fed by the DC link. So we are not depending anymore on an aging power supply, on an external power supply. We have our own one. And with that, we already improved the protection of the DC of the driver side and the controller. So the result of it is not only a better performance, but also that really protecting the bridge interface for severe catastrophic failures. So after we have done the designs on the IGBT module, but also on the driver side, we needed to test it, of course. So we ensured that the product meets the requirements of the specified application. We set up, we made a complete setup, which had to, was the same setup like you can see in the field. So there is, for example, an external DC link capacitance, which added a strain inductance and noise. So in the lab, we also need to replicate these conditions. And we tested the compatibility with the given interfaces and controls, because on the electronics changes. We tested also the added power supply and the additional fault protections, the protection functions, if they worked as specified. The challenge was that we didn't know exactly the water cooling flow on the heatsink, how it was in the field, because we realized there are different flow rates in the field due to the aging of the material, but also or the equipment, but also exchange of the equipment. So we had to go through the whole range between 6 liters per minute up to 22 liters per minute for the whole system to make the testing the complete range. So that is how the test setup looked like. So you have here on the left side, you see the diagram with the 3 phases. On the right side, you see a picture. Here you see the IGBT modules connected to the water cooling. 3 phases, 3 different systems. So what we did is, in this case, use 3 times IGBTs from SEMIKRON, but we also tested original stacks on the same platform, on the same level with different vendors, different phases. So to see the compatibility of the product. So these are the IGBT modules. Then you have an external DC link, same setup like you see in the field. Here are the power supply board. Number 4 is the bridge interface, and then also the chiller system. And with this setup, we tested the performance of the IGBT module and also compared it to the existing version which is in the field at that point. And here are the results. So you see on the right side, you see the diagram of the results. You see on the y-axis the temperature in Celsius. On the X-axis, you see the water flow rate. As I mentioned, we tested in a range of water flow ranges. So we started with 6 liter per minute up to 22 liter per minute for the whole system. On the top side, you see then the average flow rate per cold plate. So it's evenly distributed. So you have 3 times the flow rates. And you see on the right side, the small pictures, you see the locations of the IGBT modules under test. Location 1 and 3 have been original products, and location 2 has been a SEMIKRON product. And the results is on, for example, if you look at the 6 liters per minute flow, that we have a 34 degrees Celsius better temperature than with an original equipment. And then if you go up to 22 liters, you still have an improvement of 22 degrees for the test results. So that is really a great result and shows the benefit of our power electronics using this SCIM 93 module. So on the line side, we have this 22 to 34 degrees Celsius reduction. On the rotor side, we have 10 to 22 degrees. So the difference is that the line side is 1 module, 1 heatsink, and on the rotor side, we have 2 modules on 1 heatsink connected together. And you have more current. So that's why the result is a little bit different. But still, the target, as said in the beginning, was 9 degrees performance improvement. And this shows clearly this has been reached very well. So after we validated the results in the lab, we went out to the field to test it there, together with the wind farm operator. There were several visits together to tune the digital filters and to test the power supply and see if the protection functions works. So what we had seen is that also between different wind turbines, wind farms, there have been different IGBT variations, different equipment variations, which cause certain effects to the system. And with a given strain inductance, a given EMI noise we have seen in the field, we have seen our system also trip several times because it needs to be fine-tuned to meet the needs of the within this specific equipment configuration. But the important thing is, every time the system tripped, it never damaged. So there was never a catastrophic failure where we have to replace the bridge interface controller or something like that. So the protection function works very well. But of course, with all this working together with the operator, then we kept improving the system until it really ran without any challenges or problems. So we kept improving the product to make it more robust over the time. And in the end, it ran more than 6 months in the field. And as a result, we can say that we fully achieved the customer requirements. We increased the lifetime and the performance of the existing product. We replaced the failing and compromised material. We utilized the state-of-the-art IGBT modules and drivers. And we improved the performance and the thermal behavior, resulting in the end in a much lower failure rate than was previous before. And I think this is really a big success story to see. On the right side, you see one example. You see also different kind of modules here installed. And here are the SEMIKRON modules with a water connection and the SCIM 93 module. And this is now running in the field. So after we achieved this result, and we also had on the project goal, setting, running an operation, having a better performance or improved performance of 9 degrees. Now we were ready to ramp up the production. So we developed a packaging design, a complete hardware kit for the technicians out there that really can take this product go to the turbine and just exchange it. Everything is available also on the in a hardware kit, all the bolts, all the nuts, hose connections, and so on. So we increase production for that, and also for in US, for example, working together with distributors like Vex Renewables, bringing the products into the market to the customers. And of course, if there's any failures in the field, we do some root cause analysis, really to improve the product and further make it further more robust. And that's all or not? No. We still work on several kind of these projects. We had different customers, different asking for different systems in the wind and solar to review, and we are open to discuss even more projects with you. So come to us, ask us for any reliability improvement of your products, projects. Usually we look at business cases from 50 to 100 stacks per year and above, that it makes sense. But we are happy to discuss with you any further projects for the wind and solar business to improve the performance and the reliability and reduce the catastrophic failures. So far today, we have the ESS, non-ESS products available, ACS 800 power section for central solar IGBT stacks, and much more is in development right now. So for example, as a summary, the ESS, non-ESS, what I just mentioned to you. So we upgraded the product with the state-of-the-art power modules in the driver. We improved the performance, but we also increased the protection functions to avoid catastrophic failures. We have a SEMIKRON bundle where we redesigned the driver, the electronic part. We reduced significantly the amount of components on the driver, which increases the failure rate, which increases or decreases the failure in time rate and increases the reliability. We added certain protection functions, which helps to improve the system even more. Also, we have platform products which are in the field, which are you can ask us for support. We have them off the shelf, like the SemiCube, but also in case you need specific changes, adaptations, we are happy to talk to you to see if there's any possibility to optimize the system according to your needs. So that's what I wanted to tell you about for the operation and maintenance markets, one specific success story we developed in the market. And as a summary, really want to show you the key capabilities of the power electronic stacks groups. So as I said, by today, we have more than 200,000 stacks in the field, in the different variations, different markets. But the core competence is really that we know as a SEMIKRON modules and drivers, we can do the best IGBT chip and module selection for any given application. We have drivers available, including protection functions, but also allow, if required, customizations or parameterizations to adjust the product to your needs. Mechanical design based on, or developing the most optimal mechanical design with a clear cooling expertise, liquid cooled, water or air cooled, and considering, of course, your demand or your cabinet, your system design. So we also do an efficient cabinet integration considering your needs. Test and validation. Every stack leaving our factory is tested. We have for each an end-of-line test. Also test equipment for validation up to megawatt level. And if customer requires burn-in tests, shock and vibration tests is possible. And of course, on the production side, we are focusing on power electronics assemblies. So we have a very standardized controlled manufacturing process addressing exactly the needs of the power electronics demands, and working with qualified vendors with also with the SEMIKRON product to guarantee really the best and most reliable products in the power electronics area for your needs. So So far, I hope I could give you a little bit insight into the power electronic stacks and the benefits we can provide to you. And I'm looking forward to any questions either today or also later by email. Happy to hear any of your comments or questions. Thank you very much.
Thank you very much for the great presentation, Timo. And to the audience, I have just shared the presentation as a PDF. We've only received a couple questions so far during the presentation that we'll go through. If you have any more questions, we can try to get to those as we're answering these. So I would say the first question I have here is, why don't you use quick connect couplings for the cooling system?
Yes, we would like to do that, but we have to work with the existing design, which does not have the quick connections.
Okay. And how many of these O&M stacks is SEMIKRON shipped to date, specifically the ESS and the non-ESS here?
I'm not 100% sure about the latest numbers. The last time I checked was more than 1,000 pieces we have in the field already.
Okay. And are these stacks available globally?
The stacks we have shown, the ESS, non-ESS stacks, are currently available in or built in USA, but we have a global network of stack centers close to our customers. And of course, we are collaborating together to bring these products also to every customer worldwide. Yeah.
Okay. There is one question here. I think this is about SemiCube. It's saying, how difficult is it to repair a cube?
It depends on the damage of the cube, which the cube has. So I would recommend, in this specific case, you come to us, you contact us, and then we will come back to you with a discussion or suggestion. Yeah. And we have, of course, service companies to help for that as well, like solar support.
Okay. So do you offer repair services in general?
For this ESS and non-ESS stacks, for example, we can't, because we just really redesigned the product. And that's why it's not possible. We just we can't reuse what is existing. For other products like Skip, for Skip we have a repair service program, so that could be possible. So it's also on depending on the product.
Okay, I think that's everything for the time being. If we missed any, we will follow up with any more answers that we can provide. So, Timo, thank you very much for the presentation. To the audience, thank you for joining the webinar today. I hope you enjoyed it and could take away some useful information. We'd like to welcome you to future webinars as well. So see you then. Thank you and bye-bye.
Thank you.